Here we're going to talk about group 1 metals and their reactivity. So the first thing to state is that these are called the alkali metals, and we'll explain why in a minute. So the next thing to say about these is where they are on the periodic table. So if this is the periodic table, the group 1 are here. Okay, so the first column, and in this group we have got lithium, sodium, potassium, and a few more as we go down, but we only really need to use those. So whenever we talk about reactivity, we talk about electrons. So let's draw the electron configurations for lithium, sodium and potassium. So lithium has 3 electrons, so 2 in the inside ring and 1 on the outside. That makes it group 1. Next up, sodium. It has 11 electrons, so 2 in the first, 8 on the next ring, that makes 10, and 1 on the outside. Again, it's group 1. And finally, we have potassium with 19 electrons, so 2 on the inside, then 8, makes 10, then 8 again, and because it's group 1, it will have 1 on the outer ring, so there's potassium. What we're going to discuss now is why these react. Okay, so first thing to notice about group 1 is all group 1 metals have 1 electron on their outer shell. Now when they react, all these group 1 metals will lose 1 electron, because if they lose that 1 electron, they'll then have the same electron configuration as the noble gases, so they'll be stable. If they lose 1 electron, they will all become +1 ions, because they've lost 1 electron. So now we're going to look at the trend. Now a trend is a pattern. So as you go down group 1, they get more reactive. So this is the trend. Lithium's the least reactive out of the 3, potassium's the most. The reason why is because it's easier for potassium to lose this 1 electron. Therefore, if it's easiest for potassium to lose it, it's the most reactive. So we're now going to examine why it's easier for potassium to lose the electron. So, electrons are negative. Okay? So if electrons are negative, overall in the nucleus of an atom, we have more positives, because in the nucleus we've got protons, which are positive, and neutrons, which are neutral. So the negative electrons are attracted to the nucleus. Okay, so the electrons are negative, and these are attracted to the nucleus of the atom. Now, if you look at the distance between this electron, the outer electron, and the nucleus, it's not very far. Okay, so this outer electron's really close. This outer electron here that's going to be lost, again, the distance to the nucleus is that much. If you look at the final one, potassium, the outer electron it's trying to lose, and the nucleus, the distance is here. So the pattern is, at the top of group 1, so lithium, the outer electron is closer to the nucleus. You can see it's much closer to the nucleus in lithium than it is sodium. If it's closer to the nucleus, it's going to be more attracted. So top of group 1 lithium, the outer electron is closer to the nucleus, therefore it is more attracted. So this electron, the outer electron, yes, it's going to lose it when it reacts, but it's actually more attracted to the nucleus here than this outer electron is attracted here. The next point is that this outer electron in lithium only has one shell between itself and the nucleus. In sodium, the outer electron has one shell, two shells between it and the nucleus, and potassium has three shells between itself and the nucleus. We call this shielding. So at the top of group 1, so lithium, there is less shielding between the outer electron and the nucleus. Again, if there's less shielding here, okay, it means this outer electron is more attracted to the nucleus. Here, there's loads of shielding, so this outer electron is less attracted to the nucleus. So at the top of group 1, there is less shielding between the outer electron and the nucleus, therefore there is more attraction to the nucleus. So to summarise, down group 1, the outer electron is further from the nucleus and there is more shielding. These 2 points mean that the outer electron is therefore less attracted to the nucleus. Therefore, the outer electron is easier to lose. Finally, this all means that if the outer electron is easier to lose, down group 1, reactivity increases. Let's pick out some key words. So down group 1, it's all about the outer electron, further from the nucleus, and there is more shielding. It's therefore less attracted, therefore it's easier to lose. Therefore down group 1, reactivity increases.